researchers have created a new class of antibiotics using nanoparticles to battle the growing problem of antibiotic-resistant bacteria and the infections they spread.
There hasn't been a new class of antibiotics since the 1980s. We have been using the same antibiotics for years. We still use penicillin. And unfortunately, the bacteria change. They adapt. They develop resistance.
We can encounter antibiotic-resistant bacteria virtually everywhere now. At your house, at a meeting, in a hospital.
It's in these hospitals where antibiotic-resistant bacteria can pose the largest threat, especially for those who receive medical implants.
We've been dealing with medical device infection for decades. It's the most common reason for a healthcare-associated infection, is an infection of a device that we put in. And ultimately, the device has to come out, and that's a big deal if it's your heart valve or it's your prosthetic hip. And if we keep using these particular antibiotics, it will look like it was back before we invented the first one. The nanoparticle can be thought of in two different ways. One, it can be thought of like a regular antibiotic, where you would sort of either take it orally or inject it, and it would sort of treat an infection generally. In addition, we have created surfaces, materials, that are coated in them that then actually prevent biofilm from growing on them.
We can engineer them to have specific shape, specific size that can coat the catheters, pacemakers, knee joints to the very minute part of that surface.
Imagine something that's 1/100th the size of a bacteria, which is already really small, a germ. We can make it look like a tiny little pyramid, or a tiny little sphere, or a tiny little frisbee. And by changing the shape, we can control what it actually does to that bacterium. Most proteins are like little chemistry machines. They turn one molecule into another molecule. The nanoparticles could actually bind to the spot where that happens on the protein and prevent it from happening.
We're designing them to be a pretty deadly tool. They are bigger, they're heavier, they're more potent.
When you knock out that channel, the bacteria grow just fine.
Unlike penicillin and other common antibiotics, these nanobiotics are foreign to the bacteria, making it harder for them to combat and giving researchers more hope.
The process we are in now is going beyond the idea that a nanoparticle just kills the bacteria to understanding really what those molecular events are. Linking those sort of downstream events to the first thing that happens when the nanoparticle gets there will allow us to design the most efficient nanoparticle. That elevates both of us to move at a sort of more rapid rate, getting more things out to the people that need it.